Um, so elimination, the name kind of tells us what we're working to accomplish. So elimination, we're basically working to try and eliminate one of the variables by basically adding the two equations together. And that's exactly what we're going to always work to do, is add the equations and try to get the variables to eliminate. Now, when we're thinking about how a variable can be eliminated, if I have 4x and I want x's to go away, I need to subtract the 4x, right? That gets 0, and that's what I mean by eliminating, to where there's no more x's. So anytime that we have a variable that we're trying to eliminate, we need to have the same number but opposite signs. So if I had negative 7y, the value that would then help me eliminate that would be positive 7y, and that would be 0. So when we can add the variables together and get them to be 0, that's how they have been eliminated. So what we're looking for is exactly this. In both equations, do we have a variable where they have the same numbers but opposite signs? In this first example here, I see that I have a negative x and a positive x. So when I add these equations together, the x's are going to eliminate. And we're going to do exactly that. We're just going to add them straight down. Negative x plus x eliminates. Okay, those give us 0. And I'm not going to write the 0x. Okay, there's no point in doing that. It doesn't help us get anywhere. Then I'm going to do negative y plus 10y. That's 9y. And then negative 2 minus 25 is negative 27. And now I can get y by itself by dividing by 9, giving us y equals negative 3. And we got that really quick, right? It took us 2 steps to get y by itself. Had we have used substitution here, it just would have taken a little bit more work. So once I introduce elimination, I would suggest most of the time that's going to be your best method if it doesn't specify which way to solve it. But there might be some cases where substitution might make more sense. Okay, in fact, after we use elimination and solve for one of the variables, we then have to use substitution to find the value of the other variable. So now I'm going to take what y is equal to, and I'm going to sub it in for one of the y's in either equation. Okay, it does not matter which one I sub it into. So when I plug it in for the y in the top equation, there's a bunch of negatives there. This is, again, why I always suggest using parentheses when substituting in, because we have this minus a negative, which really means we're adding 3. So then I can subtract 3, get that negative x equals negative 5, and then divide by negative 1 and get that x is 5. And so our solution is 5, negative 3. And again, I'm going to always prefer that we give our answer as an ordered pair, as an x comma y, because that's what represents, right? That's what our solution represents, is where the lines intersect as a coordinate or as an xy pair. I wouldn't count it wrong necessarily if you had x is 5 and y is negative 3, but this is a little bit more relevant to what our solution represents. Okay, now on the next system here, a lot of students will notice that there's a 2y and 2y in both equations. And so they just go ahead and add them right off the bat. Okay, they cross them off and they add them and they just move through the problem like everything's ready to cancel. You have to ask yourself, though, if I add these together, they truly go away. 2y plus 2y is not 0, right? Those do not eliminate. So I've had students that'll go ahead and say, hey, we can subtract them. But that can get tricky. When we're subtracting, there's a lot of negatives to keep track of. So what I would suggest here is I know that I need one of these 2y's to be a negative 2y. So what I might do is multiply one of the equations by a negative 1, and thus changing the signs of every term in that equation. So negative 1 times negative 8x, positive 8x, and minus 2y, and now it equals negative 8. At this point, I don't really care about that first equation anymore. I'm going to go ahead and add the original bottom equation and the equation I got from multiplying by -1. 2x and 8x is 10x. -2y and 2y cancel. And then 18 minus 8 is 10. After dividing by 10, I get that x is 1. And now to find y, I need to plug this back into either original equation, including the one I crossed off, or this new equation that I have after multiplying by -1. So I'm going to sub that in. Let's do the bottom equation. So 2 times 1 plus 2y equals 18. 2 plus 2y equals 18. 2y equals 16. And y equals 8. And so our solution here is 1, 8. All right. So hopefully this feels like a little less tedious than maybe substitution can be sometimes. You're going to always be able to find the value of your first variable much quicker than using substitution. But there are going to be some times that we have to work with the equations in a different way. Okay, so again, always keep in mind what we're trying to accomplish. And it goes back to what I started with, getting a 4x and a -4x, or a -7y and a +7y. So when I get to an equation where I'm noticing that I don't have the same amount of x's, I don't have the same amount of y's, and nothing will eliminate right away, we might have to multiply, or you can even divide an entire equation in order to eliminate a variable. Okay, typically there's not going to be many where you might need to divide everything by a particular number. Most of the time multiplying will always accomplish that, but I do want to just throw it out there that dividing an entire equation by a number is absolutely okay. So what I'm noticing and what I'm trying to think about, what's the quickest way that I can accomplish getting the same number of variables, but one positive and one negative? Well, I know that, how does this stay focused? That I've got 4y here, and I can multiply 4 by a number to get 12. Camera. There we go. And so what I can do is I can multiply this entire bottom equation, kind of like what I did when I multiplied the other equation by -1, and I can multiply this by -3. And the whole reason why I chose -3 is because that's going to give me a -12y, thus eliminating the y in the other equation. So after multiplying by -3, I get 18x minus 12y equals 66. Just double checking all those signs there. Anytime we multiply by a negative, all those signs should change. And then this isn't necessary, but I'm going to just rewrite the top equation just so that I have my two equations I'm adding together stacked right on top of one another. And again, the whole point of us multiplying by -3 was to get this 12y and -12y to eliminate. Then 8 and 18 is 26x, and it equals 78. And so x equals, after dividing by 26, 3. Just like all the others, once we have a value for one of our variables, we can solve for the other by substituting this back into any of the equations we have on our paper. Okay, it could be the new equation that we multiplied by -3. It can be either the originals. It does not matter because we're finding the point of intersection, so the y-coordinate will always be the same. I'm going to plug this in just to the top equation. So 8 times 3 plus 12y equals 12. 24 plus 12y equals 12. 12y equals, I would subtract 24, so negative 12. And thus y equals negative 1. And so our solution here is 3 comma negative 1. So most of the time when we're solving a system, you're going to have to multiply one or potentially both equations to set it up so that one of the variables eliminates. It doesn't matter which one we eliminate first, x or y. We just need one of them to go away. All right, I have 2 more examples for us to work through, but before I do that, there are questions out there about multiplying the equation, any of the elimination process, or maybe even what our solution looks like. All right. So like I said, there might be times that we need to multiply just one equation like we saw in the last example, but there might be other times that we need to multiply both equations in order to eliminate one of the variables. Now, again, it doesn't matter. So in this case, when I'm like, I can't multiply 12 by anything to get 14, and the opposite of that, I can't multiply 14 by anything to get 12. Same thing with the y's. I can't multiply 6 by anything to get 7, or 7 by anything to get 6, or at least not a whole number. What I do is I pick one of the variables. Okay, and typically I'm going to pick the one that has the smaller numbers just to keep everything a little bit more manageable. So in this case, the y's. I'm like, I want to get the same number of y's. An easy way to do that is with the top equation, I'm going to take the number of y's in the bottom equation and multiply it by that. So since the bottom equation has negative 7, I'm going to multiply the top equation by 7. That's going to give me 6 times 7 y's. So then in the bottom equation, I'm going to multiply this by 6 to again give me that 6 times 7y. The only other thing that we need to consider are the signs going to be opposite, allowing us to add these together. And we already have that, right? The 6y was positive, the negative 7y was negative. So I don't need to have 7 or 6 be negative. In fact, if you make one of those negative, they will not eliminate. So now I'm going to multiply every single thing by 7. I do have plenty of calculators if we need them today, if these numbers get too big. That gives me 84x plus 42y equals negative 56. And then 6 times 14, negative 84x. And then minus 42y equals 14 times 6. We had it already. Didn't need to check it again. And 84. And so now when I add these, our whole goal was try to get the y's to cancel out, but it just so happened that we get the x's to also eliminate. So now both of our variables are being eliminated, making the left side 0 and the right side, whatever 84 minus 56 is, 28. And there's nothing for us to solve for, right? There's no x, there's no y. This is one of our special cases. So this is a false statement. And whenever we get a false statement, that means there's no solution. And thus the lines are parallel. They will never intersect. And just a reminder that if you were to add them together and you get like 0 equals 0 or something true, that would just be the opposite. That would be infinite solutions. Okay, not all. All is different. It would be infinite in that case. Most of the time, you're going to have to do something along these lines, multiplying both equations. Okay, I got one more example that you all are going to work through, but we're going to just set it up together. And so depending on what our equation looks like to start, we might need to rearrange the equation to get into a form where we can eliminate a variable. meaning, right, all the equations I've given you, the x's are on top of x's, y's are stacked on top of each other, numbers are stacked on top of each other. Down here, we don't have that, right? I have 21 on one side of the equal sign. The other equation just has 0. And so we need to rearrange our terms so we have x's and y's stacked on top of each other. To me, the quickest way to do this would be to subtract 27 from the top equation, giving me 3y minus 9x equals negative 27. And then the bottom equation, all I'm going to do with that is just essentially flip it, put my x underneath the x and the y's underneath the y's. So the bottom equation is equal to 21. We have a negative 10y. Be careful of that because it does, a lot of students will forget about that negative. And then a positive 7x. And now our equations are in a place where you can start to use elimination and solve. This camera does not want to stay focused today. So now you all take it from here. Pick a variable to eliminate. It does not matter which one. You are going to have to multiply both equations. You should end with whole numbers after you solve this entirely. Give you a couple minutes and we'll check our work together and then get you going on homework. All right, for everyone watching online, I chose to eliminate the y's, and so I'm multiplying the top equation by 10, thus giving me 3 times 10y, and so then the bottom equation multiplying it by 3, giving me negative 10 times 3y. 10 times 3 is that 30, so I get 30y and negative 30y. I want to add those together, they eliminate. And then adding the x's together, I get negative 69x, and equals our numbers, which is negative 207. Thus dividing by negative 69 gives us that x is 3. Then plugging 3 into any of the original equations, so either ones that we started with, you could even plug it into either one here. When you plug in x is 3, you end up getting that y is 0. And so our solution is 3 comma 0. And again, just want us to kind of make the connection at this point here is an x-intercept. Because y is 0. That's what's giving that away. All right, that's it for today.